Okay.
And I want to kind of let you know kind of what the plan is for today. So it is Monday, May 1st. This is our last official class meeting. Today is allotted for basically Q&A in getting ready for the final exam. You have basically 2 assignments left if you've not already completed them. One is Mini Project 7, which is related to chi-square, is due by Wednesday, May 3rd at 11:30 p.m. The final exam for the course will open tomorrow, which is Tuesday, May 2nd. It opens at midnight and will close on Sunday, May 7th at 11:30 p.m. And I want to go over, and I don't believe I've posted this document, so I'll post it. But your final exam for, it should be stat. We changed that. So let me change this to stat. For stat 2401 is not proctored. So you don't have to use any kind of special program or anything like that. You can use any of your handwritten notes, the flow charts, the PowerPoints, practice problems, or homework problems during the final exam. You will need to access and use Minitab during the final exam. You're allotted 3 hours to take it. Now, again, at the 3-hour mark, it's not going to cut you off. It simply sends me a notification that you took longer than 3 hours. You only have one attempt on the final exam, and it is primarily multiple choice and fill in the blank questions. And I would really encourage you to read the questions carefully and pay attention to the rounding guidelines. If it asks you to round to 2 places or 3 places, whatever the question asks you to do. It covers only the content in modules 3 and 4, and then I give you a breakdown. So you have a question on normality, you have a one mean hypothesis test, chi-square goodness of fit, analysis of variance, correlation and regression, a 2 mean hypothesis test, a 1 proportion hypothesis test, a 2 proportion hypothesis test, and then chi-square test of independence and chi-square test of homogeneity. So those are all the topics that we covered in modules 3 and 4. So that gives you the layout and kind of how many questions. If I remember correctly, the questions are 2 points apiece, and it is a total of 150 points. Okay, so I'm not sure that I have this document posted in the course, so I will get it posted. I'll post it when I post the video. I know that also, let me remind you that if you haven't, you have 2 bonus opportunities. One is to complete the course evaluation. You should have received in your Georgia Highlands College email, not D2L. In your Georgia Highlands College email, you should have received a link, really, or an email with links to the surveys for all of the courses you're enrolled in. Of course, this is Stat 2401. When you complete that, there's a little thank you screen at the end. And if you take a screenshot of that and then post it into the folder under assignments, you get 5 bonus points. You also can earn 10 bonus points by completing the final exam review. And again, let me remind you where you can locate that. The announcement for this week has posted. Okay, the final exam review, if you go to the landing page for the course, to assessments, and then quizzes, you'll see Stat 2401 final exam review. And that final exam review is set up just like the final exam. So it benefits you greatly to do that. Okay, so you have those 2 bonus opportunities. Any questions about any of that before I address Nana's concerns related to chi-square?
You said the course evaluation.
Well, I had a question.
Okay, hold on just a second, Disney.
Okay.
Go ahead, Nana.
The course evaluation. You said we take a picture after we complete it, and
At the
then
very end of the survey that you complete, it says, "Thank you for completing the course, this survey." Da, 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 da. You can take a screenshot of that picture and then of that screen, and then post it up to the assignment folder.
okay.
Disney, what's your question, hon?
So, well, I had two little things.
Okay.
The last quiz that I turned in, I think I got a really bad grade because I kind of like formatted the question wrong. Do you ever like go back and look at the questions just to see? Because like if the Minitab answers are slightly different, because
If
like
you will,
it was like, what's the difference between the two?
there shouldn't be a huge difference, but if you'll do me a favor, if you'll drop me an email, and you can do it inside D2L, and just ask me to look at that quiz for you when class is over, I'll look at it this afternoon.
Okay, because I think it's just two questions. Like,
Okay.
yeah, but yeah, I'll just show you what I'm talking about. And then the second one was I wanted to ask one more time how much weight the final exam was, because my class grade isn't too good, and I'm hoping that I can do better on the final, so that should help me.
Okay, let me look up something real quick. I to tell you that percentage, I need to look at the syllabus, because I can't keep it in my head how many points total there are in the class, because I have so many
Okay.
classes it's hard to keep up.
Okay.
Okay, so you have the opportunity by the end of the semester to earn 670 points total. Your final exam is 150 points. So if I convert that to a percentage, roughly your final exam is 22% of your overall total.
Okay, cool.
Now, also remember, if you look here on the syllabus, I'm going to only count the best 5 of your 7 mini projects.
Okay.
Okay.
Perfect.
So the 2 low scores will go away.
All right, that helps a lot. Thank you.
You're welcome. All right. Other questions before I address the stuff related to chi-square? Nana, I'm going to go in. I can go in and actually I've pulled the information to work through some of those problems. But it sounded like in the email that perhaps your biggest issue is knowing when to use chi-square goodness of fit, when to use test of independence, and when to use test of homogeneity. Am I reading that correctly?
Yes, and also I think on what's that? I think
Was
like
it
one on scenarios 1 and 2, like I got the chi-square. I did a little calculation, but um on Minitab I've been trying to see if I can get the same chi-square that I got on my paper, but unfortunately I got a different chi-square on Minitab, and I wasn't able to see the p-value for that one, or for those ones, I mean.
you weren't able to see the p-value for the ones you hand calculated?
Yes.
Okay. How, I guess one question I would have is, how different was your hand calculation from what you're getting in Minitab? Could you have just been making maybe a calculation error? Or was it really,
Um,
really different?
I am not sure. Like I put in uh the right data
Uh-huh.
um on the what's that on that worksheet on Minitab, and I picked what's that one of the chi-square
Test.
Yes, the test and yeah, I was getting a different one. I think on number two,
Okay.
for scenario two, I got a different one, and I wasn't able to get the p-value for that one.
Okay. Let me first kind of walk back through when to use which chi-square test, because that seems maybe to be some of the confusion. And then we'll go over and look at those scenarios that you have specific questions about. Okay, so remember we talked about with chi-square, there are a variety of tests related to the chi-square distribution. The three that we are focusing on are goodness of fit, test of independence, and test of homogeneity, and I'll list those out in a minute. And I think one of the things that you have to do when you're looking at these problems is you have to recognize, oh, I need to use goodness of fit, or oh, I need to use test of independence or test of homogeneity. So for goodness of fit, when I'm reading a scenario, basically I'm going to have information about one qualitative variable. Okay, I only have one qualitative variable. The data that you need is ultimately the frequency counts. How many times does that particular a particular category occur? So the data itself is normally presented in a categorical frequency distribution. The other thing that you may usually see with goodness of fit is it's going to be talking about proportions or percentages. You don't really deal with mean or average. It's proportions or percentages. And just because I looked this morning before we got started, I know that on quiz 12, the first three scenarios are chi-square goodness of fit. The other thing you have to remember with goodness of fit, you could have equal proportions, which basically means we're saying that all of the categories are equally distributed, or they have equal proportions. They're all the same. The second option is that you have specific stated proportions for each group. And I happen to know, again, for the third scenario in quiz 12, you have the raw data, okay, which has a slightly different approach than the other two. Okay, so then let me see if I can get it to give me another piece of paper. Well, of course you're not. Then we had test of independence. Test of independence With test of independence, you are looking at you have two qualitative variables related to one group or one sample. Typically with test of independence, the data is presented in a contingency or a two-way table. And you're going to see words like maybe independent. It could be dependent. Related to. In terms of the question. Okay.
Yeah.
I happen to know, again, because I looked this morning, that on quiz 12, this was scenario 4. And I'll go over and we'll look at them in just a minute. The third option is test of homogeneity. Okay, with test of homogeneity, your data, you still have two qualitative variables, but those two qualitative variables are related to two different groups or samples. Actually, I think I said that wrong. It's one qualitative variable related to two different groups, because you're trying to see if the two groups are the same. This one, you'll also see phrases like proportion, because you're trying to look at the proportions for the different groups. The data is also presented in a contingency table. And again, because I looked this morning on quiz 12, this is scenario 5. Okay, so Nana, you mentioned scenario 2 gave you trouble. Was that the only one?
No. Hang
All
on.
of them, or
I think a little of scenario 3
okay.
and let's see. Yeah, I think it's just 2 and 3.
Okay, I'm gonna open up quiz 12 in my preview mode. And I'm gonna scroll down or go over to scenario 2 to start. Okay, it says a researcher reads that the marital status of U.S. adults is distributed as follows. Never married is 30%. Married, 56%. Widowed, 3%. And divorced, 11%. He selects a sample of 400 people, and the results are shown below. At the 0.05 level of significance, can it be concluded that the marital status of U.S. adults is as she or he has read or is as stated? Okay, so let me copy this over to my paper so we can talk about it.
Oh no,
Let me
I just remembered scenario 1, 2 gave me just a little bit of problem. Sorry about that.
Okay, well, I'll
We'll
finish.
we'll
Can I
start with 2 already.
can I start with 2 and then I'll back up?
Yeah, go ahead. We
Okay.
already started with 2.
Okay. All right. So, a couple of things you can do here. Okay. Hopefully you realize in reading this that what you have is qualitative data, because you're talking about the options for marital status. And those options are words. Okay, if you stop and think about the question that would have to be asked, what survey question would he ask these 400 people? He would have to ask them, what is your marital status? Okay. And when he gets a reply, it's going to be a word. So I can right away hopefully recognize that this is qualitative data. The primary test that we've talked about this semester that allow us to analyze qualitative data are the chi-square. They're not the only ones, but they're primarily the analyses we can do on qualitative data. So my mind here goes immediately to chi-square. Then I need to decide, is it goodness of fit, test of independence, or test of homogeneity? Well, again, in reading this problem and looking at how my results are displayed, my results are displayed in a table. Specifically, this is a categorical frequency distribution. I also notice that I only have information on a single variable. The only information I have is related to marital status. It's not broken out into gender. It's not broken out by age. It is simply the marital status of 400 people. So the fact that it's qualitative data, I only have one variable. It also helps me that my data is displayed in a categorical frequency distribution. I land on this is going to be chi-square goodness of fit. I have one qualitative variable. Also, in the story, it doesn't talk about average, mean, anything like that. What I do have are percentages, because it says never married was 30%, 56%, 3%, 11%. So again, that may also help you, the fact that you have percentages or proportions, to recognize that it's chi-square goodness of fit. So then we begin the hypothesis test. And guys, even if you don't necessarily catch all of these clues in the story, look at the questions. You know how sometimes it's better to kind of read the scenario and maybe even read the questions before you begin? If you start reading the questions, it may very well help you to realize, oh, this is chi-square goodness of fit. Because look at how these are worded. It says does not fit, or it fits the given distribution. Okay, so it's talking about a fit in my hypotheses. So if I take the time to look ahead, so to speak, that may also help me recognize that it's chi-square goodness of fit. So we begin any hypothesis test by stating our hypotheses. In this scenario, your hypotheses are stated in words, but the words that you use in the null have to imply that it's equal or the same. The words you have to use in the alternative have to imply not equal or not the same.
I think when I did the test, I might have swapped them.
Yeah. Okay, so you got it. I mean, remember, we've talked about it for, I guess, what seems like forever. The null hypothesis for any hypothesis test must contain equal in some form. So
Okay.
I'm going to, again, thinking about what my hypothesis is, and I'm looking at, go back to the question for a minute. It says, can it be concluded, there's my key word, that the marital status of U.S. adults is as she or he has read or as stated? We want to see if this sample fits, follows, matches what they read in this article. Okay. I can say it in this sentence as it's written here, or I can say the marital status of U.S. adults fits the stated distribution. Now, that's how I phrased it. Come over here and look at these, okay? It says, what is the null hypothesis? Well, the first option that I've kind of got highlighted there in gray for a minute says does not fit. Okay, so in my mind, does not fit would imply not equal. So it has to be this second option because it says it fits the given distribution. Okay, so again, you're going to have to read very carefully. And again, think about the words. So the alternative would be that the marital status of U.S. adults does not fit the stated distribution. Again, the words imply equal for the null and not equal for the alternative. Then we need our players, which our players in this case are our categorical frequency distribution and our level of significance, which we're told in the problem is 0.05. I'm then going over to Minitab, and I basically have to enter my categorical frequency distribution. So I'm going over to Minitab. So I have marital status, I have to wake it back up. Okay, so I have marital. Come on. Marital status, and I'm going to enter the category. So I have never married, married, widowed, and divorced. And then I put in the observed. How many did I observe when I conducted my survey? And that's what information is on the frequency distribution. So there were 130 never married, 208 married, 8 widowed, and 54 divorced. Because I have specific percentages, I need to enter those because Minitab has to know what they are as well. So it was 30% never married. You have to enter it as a decimal. 56% were married. 3% widowed, and 11% divorced. The percentages are given. You have to enter them as decimals into Minitab. Then we go to, you okay, Nana?
Yeah, I'm okay. I was saying okay.
Okay. Then we go stat, tables, chi-square goodness of fit. My observed counts from the frequency distribution are in column 2. My category names are in column 1. And we are doing proportions specified by historical counts. It's based on the research. That is the expected or the specified. That's column 3. I then click OK. Now, you need your chi-square test statistic. It's under the header chi-square test. So you have your chi-square test statistic and your corresponding p-value. I would, if I were taking this on the test, I would type it in. Let's see how it's on the quiz itself. Let's see, because I don't remember if it's a fill in the blank or whatever. You would type it in and it says round your answer to 5 decimal places. Okay, so notice that chi-square gives it to you 5.58225. It gives it to you with 5 decimal places. That's why Miss Ralston says in the instructions round to 5 decimal places, because I know that's how it's given to you. Then you have the p-value, which is 0.134. And again, you would type that in. We then have to make our decision. To make our decision, we compare the p-value, which is 0.134, to the level of significance, which is 0.05. If I make the comparison, 1 compared to 0, 1 is greater than 0, so P is greater than alpha, so we fail to reject the null. So if I fail to reject the null, that means the null is true. So based on the evidence that we have, the marital status of U.S. adults fits the stated distribution. Okay, so that would be my final conclusion. I would say at the 0.05 level of significance, the marital status of U.S. adults fits the stated distribution. And again, if you look at that, I believe that's multiple choice in
Yes,
terms. Okay, so again, it requires that you read carefully. We proved that it fits, so I need the one that says fits. Okay, you gotta be careful. You can't speed read. You need to read very carefully and pay attention. I personally think it's helpful to work through the problem like we did here on the paper and then go back and answer the questions, as opposed to reading the question and looking at, and then looking at the question and going back and forth. I would work through the entire problem first and then go back and put in my answers. Okay, so I'm gonna backtrack to scenario 1. Okay, scenario 1 says M&M/Mars Company, the maker of Skittles, state that each bag of Skittles has the same number of each flavor in it. Use a 0.05 level of significance to test the company's claim. Below is the observed number in a bag of Skittles. Now, a couple of things that could, in this particular scenario, throw you off is your data, which are your observed flavors, are not presented as a categorical frequency distribution. Okay, it's not set up as a nice little table. It's just a list. But again, if I'm thinking about my data here, we're talking about flavors. Okay, so I have flavor is my focus, the flavor of the Skittle. And it's going to be a qualitative variable. And again, if I'm dealing with a qualitative variable, I most likely am going to do one of the chi-square test. Again, thinking about this, I only have one variable. I'm only talking about the flavor. So it's one variable. And I only have one group or one sample. So again, that gets me to goodness of fit. This particular problem also actually gives you the hypothesis in two different ways, because it says they state that each bag has the same number of each flavor in it. And we want to test that claim. But then it also restates that here next to expected. We can use the phrase, all the categories of flavors are the same.
Yeah, that one, I was not sure what it meant. So I did the observed minus expected squared all over the expected.
Right. But what value did you use for expected?
I added all the observed and I divided it by 5 and I got 11, or yeah,
I'm doing it.
I got 11, and each one I subtracted it by 11 and I squared it and divided to get the total. Like for lime, I did 4 minus 11 squared divided by 11 and I got 4.45, and I did the same for the others, lemon, orange, strawberry, and grape.
Okay. I'm curious. I mean, it's wonderful that you want to go through the process and do it by hand. I'm just curious, maybe why, but I mean, that's the right process. You would then do lemon, the 15 minus 11, square it, divide by 11. I mean, it sounds like you have the right process, but if some of those, I bet you, let's see, hold on just a second. Like if you use 4.45 for lime, but it's
Yeah,
really 0.45454545454545. I mean, it's a repeating decimal, and
yeah,
you rounded it. That's going to throw the number off at the end because you've rounded it intermediately. And then if you rounded the lemon calculation and the orange calculation, you're rounding, and that rounding is going to affect your final answer.
what's that? I didn't change anything on the calculator. I just like went back and pressed enter and all that long decimal.
Okay, so you kept the long decimal.
Yes, and when I put what's that? When I added them all, I wrote that long number, and yeah, I put that long number.
Do you have it like written out like on a piece of paper, and you can take a picture and send it to me? I'll be happy to look at it for you. But quite honestly,
Yeah,
I personally would not even, I mean, I know how to do it. I used to have to do it by hand. Most people are not going to do hand calculations anymore. They're going to use some form of technology to do the calculations. But I'll be happy to look at it for you
okay.
to see if it was just a calculation error or something other like that. If you can take a picture of what you have and send it to me.
Yeah,
So do you need me to finish going through this?
yes, please.
Okay, so again, we start with our hypotheses, and we're trying to say that all the categories are the same. The fact that they're the same is my null hypothesis. And again, I can literally write it this way. All the categories of flavors are the same. And my alternative would be that at least one category of flavor differs. Now, I could have said all the categories of flavors are not the same. There's different ways to say it. I'm going to toggle back over to the question and see how they had it worded. Okay. Again, pay attention to the wording. See, again, the null, we need them to all be the same. So the alternative is they do not have the same amount. At least one does not have the same amount. I said differs. Again, the phrasing, it kind of depends on the researcher, but the null should always imply whatever words you're using that it's equal, and the alternative will imply not equal. Again, my data is not given in a table form, but it's given in this list form. So I have my observed values, and I need my alpha, which again is given as 0.05. So I'm going to take this information that's in a list and put it into Minitab so that when I'm done, it kind of looks like a table. So I'm going to get a new piece of paper. This time I'm going to put the Skittle flavor. And if I look at that list, even though it's not in table form, we have lime, we have lemon, we have orange, we have strawberry, and we have grape. And then we have the observed for a bag of Skittles. There were 4 lime, 15 lemon, 12 orange, 20 strawberry, and 4 grape. Now for this problem, I don't have to enter the expected because we are claiming that they're all the same. So going into Minitab commands, I would go stat, tables, chi-square, goodness of fit test, 1 variable. Again, I have to indicate where the observed counts are. They're in column 2. My category names are in column 1. And this time we are doing equal proportions. So I leave the button next to equal proportions because I'm trying to say they're all the same. I click OK. And again, I look for my test statistic and p-value under the chi-square test header. So my chi-square test statistic for this problem is 17.8182, and my p-value is 0.001. I then am going to make a decision by comparing that p-value from Minitab to the level of significance of 0.05 that was given in the problem. So making this comparison, the first digit after the decimal in both cases is a 0. Second one, 0 compared to 5. 0 is less than 5. So P is less than or equal to alpha. So we reject the null. If I reject the null, remember that means the null is false and the alternative is true. So in this scenario, based on the evidence that we have, at least one category of flavor is not the same. It differs. So I would say at the 0.05 level of significance. And there's different ways you could say it. I might say all the categories of flavors are not the same. Now again, there's other ways to say it, but you got to say it in such a way that it implies they're not the same. Let's see how it's worded on the test. It's on the quiz itself. It says either all the categories are the same or at least one does not have the same amount.
On Minitab, for the expected, like, what if we put 11 on all 5 of them? We still get the same results?
No,
Hmm.
because if you put 11 in there and use the command of proportions,
They specify by historical count.
counts, Minitab is looking for a proportion or a percentage. The
Oh, okay.
number 11 is the count, not the proportion.
Okay. I see.
So it would make a difference. Your count here, if you have 100% and 5 flavors, would be 20% for each category.
All right. I
All right.
see.
And then scenario 3.
Yes.
Okay, scenario 3 is different because instead of giving you the data summarized in a table or a list, what you have is the raw data. This is closer to what you need to do for Mini Project 7. Because on Mini Project 7, you have the raw data. Okay, so this is raw data. And really the only thing it changes is the command that you use in Minitab. But let's read the question first. It says a teacher is explaining to her class the concepts of genetics regarding eye color. She assumes that each category will have the same number of students in it. Use a 0.05 level of significance. And then it even tells you the expected eye colors. All the categories of eye colors are the same. And it says here are the results for the class. But again, you have to start out recognizing that this is goodness of fit. So again, I have here, we have eye color. Hopefully from the list that you have of raw data, it's obvious that you have qualitative data. So again, the fact that I have qualitative data leads me to just chi-square. The only information that we collected was about eye color, so I only have one variable. So again, that gets me to goodness of fit. But we still start out the same way. We start out stating our null and stating our hypothesis, our alternative hypothesis. Again, the alternative will imply not equal, and the null will imply equal. So again, it kind of gives us this in two places because it says the teacher assumes each category will have the same number of students in it. And then it also repeats it here when it's talking about the expected eye colors. So I can use the phrase, all the categories of eye colors are the same. Again, same implies they're equal, so that's the null. And then the alternative would have to be at least one of the categories of eye colors are not the same. So in terms of, which chi-square, this one is an equal proportion. But instead of having my data organized or summarized into a table, I have the raw data. So in this scenario, I have my players are the raw data and my alpha, which again is given as 0.05. So I need to take and enter the raw data into Minitab. Get a clean sheet. Okay, so in column 1, I'm going to enter this list of eye colors. I'm going to type them in. I printed it off earlier, so we have blue, blue, green, I'm going down the column, brown, green, hazel, blue 4 times, brown 3 times, green, hazel, blue, brown, blue, brown, blue, I can spell, and then finally brown 4 times. Okay, let me make sure I didn't miss any. Okay, I must have missed 2 because I'm supposed to have 26. Okay, so blue, green, brown, green, hazel. Oops, I'm missing a hazel. Okay, so I'm going to add the hazel at the bottom. It's okay, doesn't have to be in order. Okay, so there's my other hazel. Blue, 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 brown, brown, brown. Okay, then we got green, hazel, blue, brown, okay, brown. Then I should have hazel, brown, blue, brown, blue, And I believe I'm missing a brown.
This is supposed to be 11 brown.
Okay, I'm still missing one. I know, but I'm trying to read and rotate over. Let me start over. Blue, green, brown, green, 2 hazel, 2 through 4 blues, and 3 browns.
Green, hazel, blue, brown, hazel, brown, blue,
Whoops, wait a
brown.
minute. Wait, just a second. I misspelled blue. It won't like that. Brown, okay. Blue, brown.
Blue
Yeah.
and 4 brown.
Okay, thank you.
You're welcome. I almost messed it up.
Okay, so I got all 26 now. Okay, so we've entered the raw data. So here, and guys, listen, pay attention here, because this, if you haven't done project 7, this is how you have to do it. Okay, so stat, tables, chi-square goodness of fit. This time you have the categorical data. You're going to change your option. I don't have the observed counts because it's not summarized. I have the raw categorical data. So I'm going to choose that list. We are using equal proportions. And then I click OK. And it still does the same thing for me. It gives me the chi-square, test statistic, and the p-value. So I get a chi-square test statistic of 11.6923, and my p-value is 0.020. I'm going to make our comparison of the p-value, which is 0.020, to alpha, which is 0.05. If I make that comparison, I have 2 compared to 5. 2 is less than 5, so P is less than or equal to alpha. When P is less than or equal to alpha, we reject the null. If we reject the null, that means the null is false and the alternative is true. So at least one of the categories of eye colors are not the same. So we would say at the 0.05 level of significance, at least one of the categories of eye color are not the same.
Um, in the results, for the test statistics, it says is 6.30769, and the p-value is 0.098.
Okay, I'll take a look at that one. Okay. We've been kind of, you know, I was going through it kind of quickly to try to get the data in, so I may have entered the data wrong, but I'll go back and double check it, okay?
Okay.
It could just be a typing error,
Yeah.
but I'll go back and check it. And it could just be, I mean, you know, I'll check it. But
Okay.
I want to try to move on to see what other questions anyone else has, or you may have, Nana, and I'll check that after class and see what I can do.
Okay. I think that's all. That's only those three scenarios. The 4 and 5, I did okay, and I know I did miss maybe 2 questions, but I think I figured out what was wrong. I
Okay.
think it was my fault for answering the wrong questions.
Okay. All right. Anybody else? Do you have questions related to the review sheet? If you've taken a look at it, do you have questions related to your mini project 7? What else can I do for you? Have y'all taken a look at the review sheet? Do you have questions?
I haven't looked at the review sheet yet. I had to try and study for my upcoming exam for biology.
Okay. Emmanuel, Gabriella, Disney, do you guys have questions or anything you need me to touch base on before we finish up?
Where's the review sheet posted?
Yes. Let me share my screen again. It's been in there, really it's been in there all semester. But if you go to the landing page for the course, go to assessments, quizzes, Stat 2401 final exam review. And you do get 10 bonus points for completing it, but it also gives you an idea of what to expect on the final exam. I would tell you to kind of use that review to help you maybe organize yourself, organize your notes, so that when you're doing the actual exam, you can, you know, find what you need relatively easily.
Those questions are not the same as the final.
It is not the same scenario, but the questions will be worded the same. Let me go in here and preview it for you. So it says a test for normality, and it gives you a data set. Okay, and you can pull that data set into Minitab, and it asks you to do Anderson-Darling normality for debt. Okay, you got to pay attention to the words. I may ask you, you know, this one asks you about debt. I may ask you on the final exam about income. I really don't know what the final exam one says, but it will be a similar question. Let me see if I can scroll down. Scenario 2 here is about a hotel room. Okay, see, I can change these numbers. I can change the numbers, and the question itself doesn't really change, but it's not the same question.
Hmm,
Do you understand what I'm saying?
yes.
Okay. So, but it gives you like this question, you need to be able to read this question and decide, are you doing a 1 mean Z, a 1 mean T, an ANOVA, or a chi-square goodness of fit? Okay, so the first thing I have you do is select which test you're doing. And then it goes through the hypothesis testing process. This question looks kind of similar to one that you had earlier this morning. Looks like the numbers are different. See, this was like scenario 2 on the quiz 12, but the numbers that I gave you are different. And that changes the test statistic. So you can't just copy it from what we did earlier. You have to actually do the calculations.
Mhm.
Okay. So the questions are formatted the same way that you'll see them on the exam. They're in, I believe, the same order that you'll see them on the exam. They're worded the same way, but it will not be the same numbers, if you will.
Okay.
Other questions?
I don't think I have any.
I'm going to check this question 3 and I'll go into the quiz and see if I can make an adjustment.
Okay, I'll still send you my work
That's
from
fine.
last night.
That's fine.
Yeah.
And I'll look at it.
Okay.
Anybody else have questions? If you get to looking at the review and you have questions, you can email and we'll try to correspond that way and help you kind of grasp what you're missing or what you need to know before you take the actual exam. Okay, remember the final exam opens tomorrow, which is Tuesday, May 2nd, and it closes on Sunday, May the 7th at 11:30 p.m. And you're allotted 3 hours. If it takes longer, that's not an issue, but you need to realize you need to allot at least that amount of time to take it. Be careful with your data entry, because that's one of the things I was struggling with this morning.
Real quick, that scenario 3, what I think when I put it on Minitab, I what's that? I put in the total numbers for the 4 eye colors. What's that?
Well, I see one issue in my numbers right here, Nana. Looks like maybe I have blue typed. Remember that Minitab is very case specific. So I've got my numbers messed up. I've got something about blue messed up.
Yeah, 8 blue, 3 green, 11 brown, and 4 hazel.
Okay,
Yeah.
so you went ahead and summarized the data.
Yeah, like I put in the 4 eye color, and on the next column I put in how many of those eye colors total. So I put
Okay.
8 for blue. So
Well, you can do it that way because, you know, this data set is really small enough that you can do that. But again, you need to be careful because think about it. If you had, you know, hundreds of pieces of data, okay, hundreds of pieces of data, you may not want to do that. Okay.
yeah.
And you are correct. I had something mistyped. So let me go back over here to this paper and correct this. I'll correct it before I send it out because I had mistyped one of the colors. You're right. Because after I fixed it, I did get like 6.3. Okay. So I had a typo. So the answer that you had commented about earlier was correct.
6.307 for the chi-square.
Yeah.
And the p-value was a 0.098.
Yeah, which changes the outcome too. So I'm going to correct it on our sheet that
Okay.
we were looking at before I post it. And again, that's one of the things you want to be careful about, guys. You be extra careful about typing something. Okay, in this case, we had 2 sets of eyes on it, so we were, you know, it was easy to catch it. But on the final, you won't necessarily have 2 sets of eyes on it, or you shouldn't have 2 sets of eyes on it. So be extra careful typing in the data and stuff. That's why I've allotted 3 hours so that you can, you know, have time to get it entered.
Okay.
Other questions?
I don't think I have any more.
Okay, if you should have something, you can email me. You can call and leave a voicemail and I can return your phone call as well. But otherwise, I wish you good luck with the final exam and good luck with the rest of the semester and have a good summer.
Okay. You too. Have a good
Thank
day.
you too. Thank you guys.
And the rest of the summer too.
Yeah.
Okay. Bye.
Bye.
And thank you for helping me with the quiz questions.
You're welcome. Not a problem.
Okay. Bye.
Bye.